Hello guys and girls, and welcome back to How to Prepare and Excel at Mathcounts competitions. This is part 2, and this part of the presentation is going to contain the solution to last time's challenging question and also some harder questions for you to study. This presentation was made by Dr. Hwasong Yin, who is the author of Mathcounts Preparation, How to Excel at Middle School Math Competitions, and 10 AMC practice tests to prepare for the American Mathematics Competition 8. I'm your commentator, Robert Yin, and let's get started. Now, before we begin to talk about the solution to last time's challenging question, we need to talk about triangle inequalities. So, the gist is, in a triangle with three sides of lengths A, B, and C, as shown in the picture here, A is going to be less than B plus C, B is going to be less than A plus C, and C is going to be less than A plus B. This is because the shortest distance between any 2 points is a straight line. So from point A to point B, the shortest distance is going to be line C. Now another way to go from point A to point B is to go from A to C to B, and this length would be B plus A. And since this is the shortest length, this means that line C has to be less than this length, line A plus line B. And knowing this, this means that any three positive numbers A, B, and C that can satisfy the inequalities are side lengths of a triangle. So, for last time's challenging question, if x is an integer, what is the difference between the greatest possible perimeter and the smallest possible perimeter of a triangle with sides of length 5x plus 20, 3x plus 76, and x plus 196? Now, the three sides must be able to be put in the triangle inequalities and have them be true. So what we're going to do is we're simply going to substitute these in. So we have 5x plus 20 plus 3x plus 76 is greater than x plus 196. We combine like terms to get 8x plus 96 is greater than x plus 196. We then move the x to this side and the 96 to this side to get 7x is greater than 100. And then we divide by 7 on both sides to get x is greater than 100 over 7. And 100 over 7 is 14 and 2/7. Now, 5x plus 20 plus x plus 196 is greater than 3x plus 76. We are simply just putting these lengths in different spots in order to find different values of x. So if you combine like terms, you get 6x plus 216 is greater than 3x plus 76. And then you move the 3x over here and the 216 over here to get 3x is greater than negative 140. And then you divide by 3 on both sides to get x is greater than negative 140 over 3. Now, this value of x is already explained in this value of x. So we really don't need to concern ourselves with this. It might get us, confused just having it being there, so do not worry about it. So the last arrangement is 3x plus 76 plus x plus 196 is greater than 5x plus 20. You combine like terms to get 4x plus 272 is greater than 5x plus 20. Now, if you move the 4x over to this side and the 20 over to this side, we have 252 is greater than x, which is the same as x is less than 252. Now, knowing these values of x here, we know that x must be an integer between 15 and 251 inclusive. So we can include 15 and 251. Now, to get the largest possible perimeter, we just take the largest value of x. And the same applies to the smallest value of x and the smallest possible perimeter. So the smallest possible value for x is 15, and the largest possible value for x is 251. Now, before we go ahead and input x in these lengths, we can go ahead and simplify the perimeter of the triangle. So when we add these three lengths, it's the same as saying 9x plus 292, which makes which makes the math a lot easier. So the difference between the greatest possible perimeter and the smallest possible perimeter is 9 times 251 plus 92, that is the largest perimeter, and 9 times minus 9 times 15 plus 292, and this is the smallest possible perimeter. Now, to make things easier, when you subtract the 292 from this 292, they cancel out, and then you can simply factor out the 9 to get 9 times 251 minus 15, which is 9 times 236. And mental math trick here, you can just say 236 times 10, which is 2,360, and then subtract 236 to get 2,124. It's a lot easier than just straight up multiplying by 9. So the answer is 2,124. Now, onto the first question of the presentation. Number 11. Consider an arithmetic sequence with A3 equals 165 and A12 equals 615. For what value of n is an equal to 2015? Now, before we begin, we need to know what an arithmetic sequence is. And in an arithmetic sequence, the difference between two consecutive terms is always the same. So basically, an plus 1 minus an is equal to d, and this sequence, and then d is not a dependent factor, so d is just on its own, it doesn't change, it's the same. So this implies that an minus am equals n minus m times d, or an minus am over n minus m equals d. So back to the question here. We can use these observations to find the difference of which is d. So a12 minus a3 over 12 minus 3 equals d, and an minus a12 is over n minus 12 is equal to d. And we know, and since d is the same, we can say that these two are the same, and we can solve for n. So we already know what a12, a3, and an are, because they're up here. So 615 minus 165 over 9 equals 2015 minus 615 over n minus 12. You add these two to get 450 over 9 equals 1400 over n minus 12, and 450 divided by 9 is 50, so 50 equals 1400 over n minus 12. You cross multiply to get n minus 12. No, you don't cross multiply. That's silly of me. But anyway, so n minus 12 equals 1400 over 50, which is 28. So n minus 12 is equal to 28. Sorry, n equals 12 plus 28, which is 40. So n equals 40. Okay, sorry about that. I'm getting a little tongue-tied here. So number 12. If the square root of x plus 7 equals 2 plus square root of x, what is the value of x? Express your answer as a common fraction. So to solve this, you square both sides of the equation to get rid of this square root here. So you square both sides, and when you square this, you get x plus 7, and you don't just get straight up at 2 squared plus square root of x squared. You have to remember that parentheses a plus b squared equals a squared plus 2ab plus b squared. So you would have 2 squared, which is a squared, plus 2 times 2 times square root of x, which is 2 times a times b, plus square root of x squared, or b squared. And then you simplify those, so you get 4 plus 4 square root of x plus x. The x's cancel out, and you subtract the 4, so you get 3 equals 4 times square root of x. You multiply by 4 on both sides to get square root of x equals 3 over 4, and then you square on both sides to cancel out the square root, and you get x equals 3/4 squared, or 9/16. And you can't simplify it any further because there is no other common factor. So the answer is 9/16. Now, number 13. The line perpendicular to 2x minus 2y equals 2, and with the same y-intercept is graphed on the coordinate plane. What is the sum of its x and y intercepts? Now, there's two ways to answer this question. The first way is to graph it out. So, as you can see, here's a graph. 2x minus 2y equals 2 is equivalent to x minus y equals 1, and you draw the line x minus y equals 1 by finding its x-intercept and y-intercept. The x-intercept is 1 when y equals 0, so x minus 0 is 1, so x is 1. And then the y-intercept is negative 1 when x is 0, so 0 minus y equals 1, and that would be y equals negative 1. So it's graphed out here. The black line is representing x minus y equals 1, where the x-intercept is where the line meets up with the x-axis at 1, and the y-intercept is where it meets up with the y-axis, which is negative 1. And the perpendicular line, which is this red line here, has the same y-intercept, negative 1, as stated here in the question, and the x-intercept is negative 1. So the sum of those two is negative 2, and the answer is negative 2. Now, there's another way to solve this. So before we do that, you need to know that a linear equation in the form y equals mx plus b is called the slope-intercept form, with the slope being m here and the y-intercept being b here. Now, the algebraic solution to this is to put this into slope-intercept form as y equals x minus 1. In this case, the slope is 1 because 1 times x is x, and the y-intercept is negative 1. That's right here. So with perpendicular lines, if the two lines are perpendicular, then the products of their slope is negative 1. So the new line should have a slope of negative 1 and a y-intercept of 1. Or negative 1, sorry. So that means its equation is y equals negative x minus 1. If you set y as 0, we find that its x-intercept is negative 1, and so the sum of those two intercepts for the new line is negative 2. Okay, number 14. What is the units digit of the sum of the squares of the integers from 1 to 2015 inclusive? So, for this one, there's a formula for finding the sum of the first n perfect squares, and if you've memorized that formula, you definitely have an advantage because this makes it a lot easier. So, if you don't know, this is what it is. So, we have 1 squared plus 2 squared plus 3 squared all the way to n squared, and that is the same as n times n plus 1 times 2n plus 1 over 6. And in that case, you take 2015, which would be n, and you substitute it in. So 2015 times 2016, which is n 2015 plus 1, times 2 times 2015 plus 1. So you bring down to 2015. We changed 2016 to 1008 and 6 to 3 because they both have a common factor of 2. So you cancel out the 2. And then 2 times 2015 is 4030. And then you add 1 to get 4031. Now, instead of going ahead and multiplying these numbers out to get a really, really big number and then dividing by 3, we can note that 2015 is divisible by, it's not divisible by 3. Ignore that. Obviously, there has been some problems with, spelling, grammar, but ignore that. But 2015 is divisible by 5, and 1008 has a factor of 2. This means that the sum, which is what we're talking about here, the sum, is going to be a multiple of 2 times 5, which is 10, and if it's a multiple of 10, the units digit is going to be 0. So the answer would be 0. Now, if you don't know the formula, that's okay, you can still solve it, but so all we need to do is we need to look at the units digit. That's all that's important. So for every 10 squares, so the sum of every 10 squares, it's going to look like this every single time, because we're only concerned with the units digit, which is what this is. So like we could have 1, 2, 3, 4, so on and so on, or we could have 11, 12, 13, 14, so on and so on, 21, 22, 23, you get it. We're only looking at the units digit. So this is a very repeated pattern within, all these sums. So for this, 1 squared is 1, 2 squared is 4, 3 squared is 9. Sorry. 4 squared is 16, but we're only concerned with the units digit, so we keep 6. And 25 squared is 25, but we're only concerned with the units digit, so we keep 5. And then the same is over here as was here. So in the parentheses, 1 plus 9 is 10, 4 plus 6 is 10, that's 20. So you have 20 here, 5 here, that's 25. And we are only concerned with the units digit, so we keep the 5. So this pattern happens 201 times between 1 squared to 2010 squared. And so the units digit is still 5 because there's an odd amount. So normally if there was an even amount, so you had 5, 5, that makes 10, and that's 0. So there's a 0 there. 5, 5, 10, 0. But there's 1 5 left over that isn't matched up with anything. So the units digit is still 5. But for the last 5 squares, so 2011, 2012, 2013, 2014, 2015, you have this. So this is, again, 20 plus 5 is 25, so you're left with 5. And the 5 left over from here and the 5 here makes 10, and the units digit is 0. So the units digit of the whole sum is 0, and that is your answer. So number 15. The doctor gave Amber 10 vitamins with instructions to take 1 or 2 each day until she runs out of vitamins. For example, Amber can take a vitamin a day for 10 days, or she could take 2 the first day and 1 a day for the next 8 days. A third way is to take 1 vitamin a day for 8 days and 2 on the 9th day, including the 3 examples given. And how many different ways can Amber take the 10 vitamins? So there's 2 solutions for this. The first one is going to involve recursive calculation, and it's going to be a lot simpler. So I'm not going to go in too much on recursive calculation. That is something to be dealt with maybe a later time. And at the end of the presentation, we will give you another way to learn more about recursive calculation. So let an be the number of ways to take n medicines if she is to follow the same instructions. For example, a1 equals 1 and a2 equals 2. Assume that n is greater than or equal to 3. If she takes 1 medicine the first day, there are n minus 1 medicines left. There are n minus 1 ways to take the rest n minus 1 medicines. If she takes 2 medicines the first day, there are n minus 2 medicines left. There are n minus 2 ways to take the rest n minus 2 medicines. This gives us the recursive formula an equals an minus 1 plus an minus 2. The sequence of this is going to be 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. And this is formed by taking the sum of the last 2 terms. So like 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on and so on. And so A10, which is what we're looking for, is going to be the 10th term, and the 10th term is 89. So your answer is 89. So there's 89 ways. Now, if you didn't know this, there is another solution, which is just counting by the cases or the different ways she can take the vitamins. And it's going to be a little bit messy because there's a lot. But, sorry, anyway, we arranged it in a table in order to keep it organized and to minimize the amount of mistakes we make. So, on the left hand, we have number of days she takes 2 medicines. The middle is the explanation, and the count is on the right hand side. So if she doesn't take 2 medicines in a day at all, she'll just take 1 medicine for 10 days, and that's just one way to do that. Now, if she takes 2 medicines for 1 day, she has 9 days total, and she chooses out of those 9 days which day she's going to take 2 medicines. So that is 9, choose 1, or 9. And so if she takes 2 medicines for 2 days, she has 8 days, and she chooses those 2 days, which is 8 choose 2, which is 8 times 7 over 2, which is 28. Now she takes 2 medicines for 3 days, she has 7 days total, and she chooses 3 of them to take 2 medicines. So she has 7 choose 3, which is 7 times 6 times 5, over 3 factorial, which is 35. So if she takes 2 medicines for 4 days, she has 6 days, and she chooses 4 days, which is 6 choose 4, or in this case we could do 6 choose 2 because she's really just choosing which 2 days she takes one medicine, and 6 choose 2 is easier to calculate than 6 choose 4. So 6 choose 2 is 6 times 5 over 2, which is 15, and if she takes 2 medicines for 5 days, she just has 5 days and she takes 2 medicines for all the days, and that is one case. So the total count, you just add it all up and you get 89. So if you haven't already checked these 2 books out, I would recommend to do so. They are Mathcounts Preparation, How to Excel at Middle School Math Competitions, and 10 AMC 8 Practice Tests to Prepare for the American Mathematics Competition 8. These are both by Kwasong Yin, and they have a ton of solutions to questions like the one we have answered today. We'll continue to answer these questions for your benefit, and if you have any suggestions, let us know. Obviously, we probably do need to proofread this presentation more, but if you have anything else, like, things you wanted us to cover, maybe we'll make like a separate video on something like recursive calculation. If you want to learn more about that thing, let us know, and we're going to continue next time, so stay tuned.